Welcome to EDU World Space.
The problem 70 in chapter 19, part A. We're going to calculate the number of delta H0 and delta S0 for the reaction. So delta H0 of a reaction is equal to the delta H0 of the formation of the products minus the delta H formation of the reactants. So that is equal to the delta H of formation for CH3OH gas minus the delta H formation of the products, which are CH4 gas, and 1/2 of the delta H0 of formation of the oxygen gas. So this is equal to negative 201.2 minus negative 74.8 minus 1/2 times 0. And you will get a number of negative 126.4 kilojoules. And then delta S0 is equal to S0 of the product, which is CH3OH gas, minus S0 of CH4 gas, minus 1/2 of S0 of oxygen gas. And you will get 237.6 minus 186.3 minus 1/2 of 205, and that is equal to negative 0.0512 kilojoules per Kelvin. All right, so part B is asking you how will the number of delta G change when the temperature increases. So we know that the delta G0 is equal to delta H0 minus T delta S0. So from the above, we know that delta S0 is a negative number. Temperature is always a positive number. So this entire part will be positive. So when T increases, the number of delta G0 will increase. So delta G0 will become more positive as temperature increases. Part C asks us to calculate the delta G0 at 298 Kelvin and decide whether it's spontaneous or non-spontaneous. So delta H minus T delta S0 is equal to negative 126.4 kilojoules minus 298 Kelvin times negative 0.0512 kilojoules per Kelvin, and that is equal to negative 111.1 kilojoules. So since this number, delta G0, is negative, so the reaction is spontaneous. Part D, is there a temperature at which the reaction will be at equilibrium under standard condition, and that is how enough, is it low enough so that the compounds involved are likely to be stable? So at equilibrium, we know that delta G0 is equal to 0. So in this case, delta H0 is equal to T delta S. So the temperature will be equal to delta H divided by delta S. That is equal to negative 126.4 divided by negative 0.0512. That will give you a temperature of 2470 Kelvin. So this temperature is very high, and at this temperature, the reactants and products are likely to decompose, so it is not stable. So at standard conditions, equilibrium is non-attainable for this reaction.